I apologize that the notes may not all get into the screen here, but you have the notes in front of you so you can read along as we go. We'll be solving equations containing variable exponents. In other words, the x that we want to solve for is in the exponent position. And the instructions say the first step would be to isolate the number that has the exponent. And then we're going to take a logarithm of base 10 to both sides. So let's just start into the first example. Okay. I already have 3 raised to the x power, and my video may be a little out of focus, I'm sorry. But 3 to the x power is equal to 15. Okay. The 3 to the x is already by itself, so I'm ready just to take the logarithm of both sides. So log of 3 to the x is equal to the log of 15. Oops. Okay, I'll get a little better at this. Now, using our power property, we can bring the x to the front. So I'm going to rewrite that as log x in the front of log 3 is equal to log 15. And remember, I'm wanting to solve for x. So to do that, this is actually multiplied by this. So I would divide by the log 3, both sides. And I have x is equal to the log 15 divided by log 3. Now I'll just put that into my calculator. Remember, using the log base 10 button. And I should get, and don't forget to close your parentheses as you put it in. Log 15, close the parentheses, divided by log of 3. And you should get approximately 2.465. So that was fairly easy. So let's see if we have a number in front. Okay. So in the example of number 2, we have 4 times 5 to the 2x raised to the 2x power is equal to 64. Okay. Now remember, my first step would be to isolate the number that is raised to the exponent. So this is 4 times, so I can actually divide by 4 of both sides. And I have 5 raised to the 2x power is equal to 64 divided by 4, and you can put that in your calculator, is 16. Okay. Now the second step would be to take the logarithm of both sides. Okay. And if we want to go ahead and do a step ahead, we know that we're going to take this and write it in the form of using the power property, meaning the 2x, the exponent, is going to be in front. The power is in front. So 2x log 5 is equal to the log of 16. And we're solving for x, so I want to get rid of everything around that. So I will divide by log 5, both sides. Okay. And I can go ahead and put that in my calculator, and I'll have 2x is equal to, in the calculator on the log button, okay, log 16, close the parentheses, divided by log 5, and it should get about 1.723. We're going to round to 3 places. Okay, now I'm not finished because I have x here, 2x, and I need to now get rid of the coefficient that's in front of the x, and that's times, so I do the opposite. So divide by 2, divide by 2, and I should get now x is approximately, in the calculator, 0.8615. Kind of hard to read. Follow. Okay, so example 3. I have 6 to the 2x is equal to 21. And I know it's hard to see these small numbers in here, but you can see what I'm writing. And again, you're following along on your own paper. Okay. So 6 raised to the 2x is already isolated, so I'm going to take the logarithm of both sides. And if we want to go ahead and write that in the front, we can. Okay, so let's just go ahead and put that there. Log of 2x. 2x of log 6 is equal to the log of 21. Now, again, isolating the 2x, I divide by log of 6 on both sides. Okay. And I have got 2x is equal to, in the calculator, this should get me 1.699, and I'll round that to 1.70. And I need to, again, get the x all by itself, so I would divide by 2. And divide by 2. Therefore, x is equal to approximately 0.85. Okay. And remember, we can always check our answers back in by plugging this in. 6 raised to the 2 times 0.85, and it should be approximately 21. Okay, one more example on these. Okay, we have 2 times 1.5 raised to the x is equal to 6. I want to isolate this area right here. So I'm going to divide by 2 on both sides, and I have 1.5x is equal to 6 divided by 2, which is 3. And then taking the log of both sides, I'm going to go ahead and use that power property and put the x in the front. I've got log of 1.5 equals the log of 3. Getting x all by itself, I divide both sides by log of 1.5. And I'm going to put that in my calculator and get x as approximately 2.71. So the next example, number 6, is really just like the other ones. So this will be the end of that, and we'll do part 2 to do the solving equations containing logarithms, the second part of this note paper.